Planets are the celestial bodies which revolve around the sun in definite paths or orbits. Okay, so they revolve around the sun. As satellites, moon, they revolve around the planets. In the same way, planets revolve around the sun in definite paths. Okay, or orbits. They do not emit light of their own. They are non-luminous. Is there any problem? Is there an irritation in your eye? You fine?
Yes.
Or you can wash your face.
No.
No need. Okay. So they do not emit light of their own like a star. Stars have their own light. Stars have their light because there are kind of, nuclear reactions that take place inside the stars, even in the sun, because sun is also a star. So there are nuclear fusion reactions that take place inside the stars. And this is the reason, tremendous amount of heat, tremendous amount of energy is released in the form of heat or light, and therefore they shine, they emit light. But for planets, there is no nuclear reactions taking place like in stars and sun. We find nuclear reactions in the same way. uh, those level of nuclear reactions do not take place in planets, and therefore they do not emit light because there is nothing emitting from them. And but how do we see planets then? Planets, satellites, they do not emit light, but we can see planets, we can see satellites. How do we see them? Because they reflect the light of sun falling on them. How are you able to see me? You can see me clearly, right? How are you able to see me? Because I'm sitting in a light room, okay, and we have number of lights on the ceiling, and light is incident on me and it is reflected from me. I'm a non-luminous thing. I am non-luminous.
Yes.
I am not emitting any light. But you can see me because I am reflecting the light falling on me. Okay. If I'll sit in dark room, then can you see me in the dark room? No. You'll find it hard, na? You can't see me in the dark room because in the dark room there is no light. And how would you see me? In the same way, planets do not have their light, satellites do not have their light, but we can see planets and satellites because they reflect the light falling on them. Okay? And they become visible. They are non-luminous. They do not emit light. Next. What is period of revolution? All planets revolve around the sun in specified orbits. Okay. And period of revolution is the time taken by a planet to complete one round around the sun. To complete one revolution around the sun is time period of revolution of a planet. And we have also time period of rotation. See, planets revolve around the sun and they also rotate about their own axis. They move like this. Revolution and rotation both are taking place simultaneously at the same time, like this. So they also rotate about their axis, and time period by a planet to complete one rotation is called period of rotation. Okay. Yes, one more point is there. Gravitational attraction between the sun and the planet hold them together. So all the planets revolve around the sun because there is a kind of force which bind them together, and that force is called gravitational force. So it exists between Earth and the sun, it exists between different planets, it exists between other planets and the sun, satellites and the planets, it is everywhere. Okay, and it holds everything together. So how are planets different from stars? See, planets do not emit heat and light on their own, do not have their light. And on the other hand, stars have their own light. They emit the sunlight. They emit the light because there is a kind of nuclear fusion reactions taking place inside the stars. It is mainly made up of hydrogen and helium. And because of nuclear fusion reaction, tremendous amount of energy is released, and they emit light. They emit that heat, they emit that light, and they appear brighter. On the other hand, there are no such reactions taking place in planets, and therefore they do not emit light and heat on their own. This is one difference. Second difference is that planets keep changing their relative position with respect to stars. On the other hand, stars do not change their relative positions with respect to each other. Okay? Third difference is that planets do not twinkle. On the other hand, stars appear to twinkle at night. And this twinkling of stars is because of atmospheric refraction, and it is one of the phenomena of light that you'll be studying in class 10. Okay. In I think in lower classes also they teach refraction of light, right? Atmospheric refraction is the thing because air density is different. Somewhere air is, denser, and somewhere it is rarer. And due to difference in air density, when light, it travels towards the Earth's atmosphere, so it travels through the different layers of atmosphere. Some layers are denser and some layers are rarer, and due to which light changes its path many times and it refracts. It deviates from its path, and we see stars appear twinkling because they are very small in size. They appear to be very small in size. They appear to be point size, though they are not, but they appear to be point size. And sometimes we see the light coming from them, and sometimes we do not see the light coming from them, and therefore they appear to twinkle. Okay, so these are the three main differences between planets and stars. Please write all these differences. Okay, Lavansh, why do planets keep changing their relative positions with respect to stars?
Planets, what?
Because they rotate, they revolve. They revolve and they are not fixed like stars, and therefore their relative position with respect to stars appear to be changing. On the other hand, stars do not change their relative positions with respect to each other because they are fixed. Though, see, everything is moving in the universe, but their relative position means the distance between two adjacent stars or two nearest stars, we can say it is fixed. We say now that universe is expanding, everything is moving away from each other.
Yes.
This is happening. This is Big Bang theory. We accept that, but the relative position means between the two stars, distance is fixed. Though everything is moving in the universe, but between the two stars, the distance is fixed. On the other hand, for planets, they revolve every time, they rotate about their axis, they revolve, their positions change. And this is the reason their relative positions with respect to stars appear to be changing. So, this is a solar system. A solar system consists of the sun and 8 planets, and these 8 planets revolve around the sun in specific orbits. You can see that this is, which planet is this? This is Mercury. It is the nearest planet of our solar system. It is nearest to the sun. And then we have Venus, Earth, and this is Moon. So Moon is a satellite. It revolves around the Earth. And then we have Mars and Jupiter. Jupiter is the largest planet. And then we have Saturn, Uranus, and Neptune. We can see rings around the Saturn. We can also see rings around the Uranus. And there are rocky material. You can see pieces. And all these pieces, they also revolve around the sun like planets revolve. And they are called asteroids. Okay. And they are, they lie between the orbits of Mars and Jupiter, we can see. So this is Mercury, and then we have Venus, and then we have this Earth, and we have Mars. After Mars, we find these rocky substances, rock particles, and then we have this Jupiter. These are very huge rocks. very giant rocks, very big rocks. And they also revolve around the sun as other planets revolve in the same way. And then we have Jupiter, Saturn, and Uranus and Neptune. Earlier, Pluto was the 8th planet of our system, but now it is not considered as a planet. Okay, we consider Pluto as dwarf planet now. Pluto revolves around the sun, but that's why we consider Pluto as a subplanet. It is a dwarf planet, and there are certain, conditions for a celestial body to be considered as a planet. And Pluto does not fulfill all those conditions. And this is the reason it was rejected as a planet and accepted as a dwarf planet. Okay. So, yes. So first planet is of our solar system is Mercury. So Mercury is the smallest planet of our solar system, and it is the nearest planet to the sun, and it is almost the same size as the moon. It is very small in size. It is nearest, almost the same size as the moon, and it has no atmosphere, and its surface is rocky and mountainous. We have mountains everywhere on the surface of Mercury, and it has no atmosphere of its own. It doesn't have any atmosphere. It is the smallest planet in a solar system, and it has no satellites of its own. No satellite, no natural satellite revolve around the Mercury. Okay. And in how many days Mercury completes its one revolution around the sun? Any idea? It is 88 days. It completes its one round around the sun in 88 days. Okay. And because it has no atmosphere, so why is life not possible on Mercury? Because it is closest to the sun. It is quite hot. We cannot bear that much heat. Okay. So life is not possible because there is no air, there is nothing. It's totally rocky and mountainous. So life is not feasible there. अच्छा, आपको ये पता है कि sun also exert pressure? There are certain kind of rays, radiation pressure it exerts on us. बोलते हैं ना लू लग गई है, तेज गर्मी थी. So there is a kind of radiation pressure which has been exerted by the sun, and the planets which are closer to the sun, they feel that radiation pressure greater. And it's difficult to, stay with that radiation pressure. Solar winds are there, radiation pressure is there. There are a number of reasons. So when we talk about life, we consider not just one reason. So we have a long list of reasons for survival. There should be water, there should be air, there should be atmosphere, less air radiation pressure, no ultraviolet rays should be there. Number of things that we consider. Please write this first and then we'll move to the next slide. After Mercury, we have Venus. Okay. Venus is the second nearest planet to the sun. Okay. It is also known as morning and an evening star. It has a very thick, cloudy atmosphere around it, which reflects 3/4 of the sunlight falls on it, and therefore it is the brightest planet in the night sky. It has no satellite of its own. Its mass is nearly 4.5 times that of the Earth, and therefore it is called Earth's twin. Venus is called Earth's twin because Earth and Venus, they are of same masses, nearly same mass they have. And this is the reason it is called Earth's twin. It is a nearest planetary neighbor. It is the nearest planet to us, and it rotates from east to west, whereas Earth rotates from west to east. Earth rotates from west to east, and this is the reason we see the sun rising from the east and setting in the west. Okay, because Earth is rotating from west to east. So we see everything rising from the east. This we had discussed in previous class also. But Venus, it does not rotate the same way as Earth rotates. It rotates differently. Okay, it rotates from east to west, not from west to east. Sometimes they ask this question as well. Name the planet which rotates from east to west. Okay.
Hmm.
It shows faces like the moon. As moon shows different faces, sometimes moon appear bigger in size, sometimes it is smaller in size, sometimes we see crescent moon, sometimes we see full moon or new moon, right? In the same way, Venus also show faces like the moon. Okay.
Hmm.
Now you are supposed to write this, but we have very few minutes left, only 3 minutes left. So we'll start our planet Earth in the next class, and please take the screenshot first and then start writing. Okay. Let's start with a planet Earth. So do you know the distance between the sun and the earth?
It's about 15 crore, I think, or anything like 15.
It's nearly 1.5 into 10 raised to the power 11 meters. And how much time light takes to reach the earth?
18 minutes.
No, it's not 18. It's 8 minutes and 20 seconds.
Oh, 8 minutes.
So light takes 8 minutes and 20 seconds to reach the earth. So in just 8 minutes and 20 seconds, light covers a distance of 1.5 into 10 raised to the power 11 meter in just 8 minutes and 20 seconds. It travels so fast. So what is the speed of light?
3 into 10 power 8.
Yes, it is 3 into 10 raised to the power 8 meter per second. So it is the only known planet. Earth is the only known planet to have life on it, where life can exist. So, what are the suitable conditions you feel exist on Earth, which makes it perfect for life?
First, that there's a suitable like atmosphere.
All right.
There's water on it,
Hmm.
and then there's a ozone layer that protects us from the
Harmful
ultraviolet
ultraviolet
ra-
radiations.
hmm,
And
ultraviolet radiation and
see, it has atmosphere around it, and Earth has atmosphere. That's because of the gravitational force of Earth. Due to its gravity, there is air around us. And what are the different layers of
and
atmosphere?
you have a correct distance from the
Yes,
sun
very good.
to
It is
have
at
a
correct distance, not too hot, not very cold. Yes, so it has
yes,
atmosphere around it is one reason. And Earth rotates around an imaginary axis. Imaginary axis means axis which does not actually exist. If we assume that we Earth as a ball, and there is a stick. If you have a stick and a ball, so if you pierce the stick into the ball, then through one end, then it can we can take it out from the other end, so that
yes,
it can be considered as an imaginary axis of the earth,
axis.
and earth rotates about that axis, this
Mm.
like this. Okay, so if we assume this as earth, so earth rotates like this. So what is the imaginary axis? This line is the imaginary axis of the earth.
Like
And it,
it's imaginary, it's not real.
yes, it's not real. We just imagine it. And the day and night occur due to the rotation of Earth, because half of the Earth is hidden and
Uh,
half of the Earth faces the sun. The part of the
yes.
Earth which faces the sun is
Like in India, there's morning, I think, morning or afternoon, and here
yes,
it's night.
yes. This is the difference. Okay, and this is because of rotation of Earth. about that imaginary axis, and we assume that imaginary axis to pass through the poles of the Earth. Okay. And this axis of rotation is tilted with respect to the plane of the orbit. It's like this, a little tilted. Tilted, you understand?
Yes.
ऐसा टेढ़ा होता है वो, ठीक है? It is not like this. Yes, it is tilted. And the change of season takes place due to tilting of its axis of rotation and change in its position with respect to the sun. Now, because of this tilting of its axis of rotation, there is change of seasons and change in position with respect to sun. Earth appears to be bluish green from space due to reflection of light from water and land mass. Okay?
Yes.
And the factors that made it possible for life to exist on Earth are as following. Number one, Earth is at right distance from the sun so that its temperature is moderate. It is not very hot or neither hot nor cold. Not very hot, not very cold. It has a moderate temperature, so where life can survive.
Exist.
Yes, exist. So there is water on Earth. 70% of the Earth is covered with water.
Water.
And atmosphere is suitable. The atmosphere of the Earth is suitable for life to exist. And we have a blanket of ozone layer. We have a ozone layer in the stratosphere of the atmosphere, and that ozone layer protects us from harmful ultraviolet radiations. Okay.
Yes.
Ultraviolet radiations are those radiations which come out of this, which sun radiates. Sun has three types of radiations. Sun rays carry three type of radiations. Ultraviolet radiations is one of them. Second one is infrared rays, and third is the visible light, the white light that we see. Okay. So our next planet is Mars. Mars is also called as red planet. It appears red in color, and its mass is 1/10 of the Earth. Diameter means
The half, like the half,
9
the half of the,
yes. So diameter signifies the size of the planet in this case, right? Because planets are spherical in shape. It has a thin atmosphere around it. It has a very thin atmosphere around it, and it has two satellites named Phobos and Deimos. Phobos and Deimos are the two satellites of the Mars. These are the natural satellites of the Mars. Okay. Next planet is Jupiter. See, Jupiter is the largest planet of all. We have 8 planets in our solar system. And out of 8 planets, this planet is the largest planet. And it is called Brahaspati in Hindi. And the mass of the Jupiter, it is more than the combined mass of all other 7 planets that we have in our solar system. So it is the largest planet in our solar system. Its mass is more than the combined mass of all other 7 planets. Means if we combine the mass of all the 7 planets that we have, okay, other than Jupiter, then its mass is greater than the combined mass. Okay. Next, because it is quite massive, so it's obvious because it is quite massive, so it has a thick atmosphere around it. And it has a strong gravitational force. It has a thick atmosphere around it, and it appears very bright. It appears very bright because most of the sunlight falls on it is reflected. It reflects most of the sunlight falling on it. And its atmosphere consists of mainly methane gas, methane and ammonia in crystalline form. These are poisonous gases. Methane gas is very poisonous gas. Okay. It has a faint system of rings around it. As Saturn carries rings, Uranus has rings in the same way. Jupiter has also faint system of rings around it, and it has 28 satellites revolving around it. Okay. See how many satellites, natural satellite, Earth has.
1.
Size is 1300 times that of the Earth. Size of the Earth, and its mass is 318 times that of Earth. So next planet is Saturn. So Saturn is the most distant planet known to early astronomers. For early astronomers, Saturn was the most distant planet, and it appears yellowish in color. There are three distinct rings that surround it, and these rings are visible with the help of telescope only. We can see these rings through telescope, and it is least dense planet. Its density is less than that of water. It is mainly made up of hydrogen and helium. And this is the reason we say that Saturn can float on water. Sometimes, you might have heard that Saturn can float on water because its density is less than the density of water. So any substance whose density is less than that of water can float on water. And substance with density greater than water will sink in water. So it is assumed that if Saturn, if you place Saturn on a sea or any water body, then it will float on the surface of that water body. Okay, clear? Yes. And it has 62 satellites, and its largest satellite is Titan. Titan is the largest satellite of Saturn. Please write all these points in your notebook now. So our next planet is Uranus. Uranus was discovered by William Herschel in 1781, and its diameter is 4 times that of Earth. Means it is larger in size. Yes, it is larger in size, and it has hydrogen and methane in its atmosphere. And it, like Venus, it rotates from east to west. See, there are two planets in a solar system which rotate in opposite direction. All except these two planets, all the remaining planets, Mercury, Earth, Mars, Jupiter, Saturn, Neptune, they rotate from west to east. So these are the only planets, Uranus and Venus, okay, which rotate from east to west in opposite direction. And as its rotational axis is highly tilted, it appears to roll on its side like a ball. In Earth, when we were discussing about the Earth, then also we had taken this rotational axis, no? It is tilted, you know? In the same way, Uranus axis, rotational axis is also tilted, but it is highly tilted. It is highly tilted, so it appears to roll on its side like a ball. The next planet is Neptune. Neptune existence was predicted by Leverrier even before it was seen, and it has 8 natural satellites. Okay, so it is the last planet of our solar system and the Jupiter. Okay, please draw this in your notebook. So this is the radius of Earth. Let's write the radius of Earth as capital R and subscript small e. And this is the radius of the planet Jupiter. Let's write the radius as capital R with subscript J. Okay. So we know that radius of Jupiter, it is given to us. Given to us. That radius of Jupiter is 11 times the radius of Earth. To find, first we have to find the ratio, volume ratio. Volume of Jupiter divided by volume of Earth. This is what we have to find, number one. Okay. And second thing that we have to find out is how many Earths the planet Jupiter can accommodate. This is part 2. Okay, now we will be solving these two parts one by one. So let's start from the first part. In the first part, we have to find the volume ratio. If we assume Earth and Jupiter as perfect spheres, they are perfectly spherical in shape. Though Earth is not perfectly spherical in shape, it is spheroidal in shape. But if we assume that Both the planets are perfectly spherical in shape. Then, how do we find volume of a sphere or a spherical shell? How do we find volume of a sphere if radius is given? Do you know the formula?
No.
No? See, it's 4 by 3 pi r cube. You haven't done mensuration. No. If we have a sphere, then we can find its volume by 4 by 3 pi r cube. Okay?
Hmm.
This is the formula. So if you know the radius, you know the value of pi?
Pi, yes,
What is
22/7.
it's 22 by 7 in decimal, we write 3.14, है ना?
Hmm.
Yes.
Yes.
Now, because this is the formula of volume, so we can write for Jupiter as Vj. So it's 4 by 3 pi r j cube. This is the volume of Jupiter. Similarly, we can write for Earth. So volume of Earth is Ve. It's 4 by 3 pi into radius of Earth, cube of radius of Earth. Okay. Now, because we have to find this Vj by Ve. So for this, we need to divide these two.
Hmm.
So let's divide. So Vj upon Ve is equal to, first write for Jupiter, it's 4 by 3 pi rj cube. And now write for Earth, it's 4 by 3 pi re cube. 4 by 3, 4 by 3 will cancel. Now we have this Vj by Ve, and this is equal to rj cube upon re cube. So we can write rj by re whole cube. Can we write like this?
Yes.
Yes.
Cube.
Now look at this. The thing which is given to us. Rj by re is
Uh, Rj by Re.
we can find Rj by re from here, na? Rj is 11 re. Yes. So when this 11 goes there, because it is multiplying here, so we'll transpose it. It gets divided. No? When we
Yes.
move the variables, then what do we do? When we move the variables, we move like this, na? If this is x is
Yes.
equal to 2y, then what do? We write x upon y is equal to 2. This is how we do.
Yes.
If something is
Yes.
getting multiplied here, then it gets divided on the other side.
Hmm.
In the same way, we'll do for RE and RJ. Now tell me what should I write now?
Rj and 11. It's 11 Re.
Yes.
So Rj by 11.
RJ by RE. If I want to move this RE, then what should I write?
Okay. Rj by Re is equals to 11.
RJ by RE is equal to 11. Yes, because we want this RJ by RE. Na? That's why I have moved RE. I want the value of this ratio.
Hmm.
Okay.
Yes.
So it's nothing. It's just 11 cube. So what is cube of 11? You've done cubes and cube roots. You
Yes.
haven't done. Done. So how do we take cube of a number? We simply multiply the number 3 times.
Yes.
So 11 has to be multiplied thrice. When we multiply 11 two times, what do we get?
11 two times we get
121.
20 to 121.
Now 120 into 11 is?
121 into 11.
See, it's 1331. We can directly do this. I'll tell you the trick. How should we multiply any number with 11? It's very easy. There is a trick. You simply write 1 and this one. Okay. The extreme numbers that we have, write like this. Now in this, after 1, we have 2. So simply add the numbers 1 plus 2. Now we have 2 and 1. Now add the numbers 2 and 1, and then you will get 1. 1 plus 2 is 3. 2 plus 1 is 3 and 1. So 1331.
Okay.
It's interesting, na?
Hmm.
So we can easily multiply numbers like this. Any number by 11 like this. See, in the same way we can write for this 11 square. It's 121, right? So we can write 11 like this. And then we have only, at two extremes, this one here. 1 plus 1, we'll write in the middle. So it's 121. Okay, so this is how we multiply. This is one way of multiplying any number by 11. So we get Vj by Ve is equal to 1, 3, 3, 1. Okay, now we'll move this Ve to the other side and we get Vj is equal to 1, 3, 3, 1 into Ve. So ratio we know. Ratio is, what should I write here? Tell me. You tell me. Ratio is 1, 3,
1, 3,
3,
3,
1 is
VE.
to 1. Next question is, how many Earths Jupiter can accommodate? Can we get this value from this ratio? How many Earths Jupiter can accommodate?
Yes.
What should I write? Okay, have you done questions like this, that if you have three balls in surface areas and volumes, you might have done that you have, three balls like this of radii 2 centimeter each. Now you have reformed the balls by melting, and when you melt the balls and you form a bigger ball. Have you done questions like this? Then find the radius of the bigger ball. So these balls have had equal radii, let's say R for each ball. Now the bigger ball is of radius capital R. And see, because we have melted it and reformed it. We have reformed it and a new ball has been formed. Now, how do you find, see, R is given it's 2 centimeter and you are asked to find capital R. Then how do you find capital R?
Capital R like
किसी भी चीज को अगर आप मेल्ट कर रहे हो, रिफॉर्म कर रहे हो, and giving it a new shape, then which quantity remains the same?
I did this question.
Volume.
R.
Volume remains the same. So what we do is, we will multiply the volume of all the three balls. Volume of one ball is 4 by 3 pi r cube and three balls is 3 into 4 by 3 pi r cube, and we just keep this equal to 4 by 3 pi capital R cube. So in this way we get the value of capital R. This is how we solve these kind of problems. So now again, something in volumes is given like this. So we can say that how many Earths, the question is, how many Earths Jupiter can accommodate? So if we have volume C, volume of Earth has been multiplied by 1331, only then we are getting this volume of Jupiter. It is multiplied by 1331. We have multiplied it, na? Then we are getting Jupiter volume. If it means that if we have this number of Earths and we are just adding the Earth's volume, then we can make a Jupiter. Then how many Earths do we require to make a Jupiter? It's 1331 only. 1331 Earths are required to make Jupiter. Okay? Or 1331 Earths the planet Jupiter can accommodate.
Okay.
If you have any doubt anywhere, even a simple doubt, you can ask me right now, because this question is very important.
No.
Tell me. No doubts at all?